Hello guys, so you should be able to have filled this part out on your own. So mostly this is just to give you a chance to see if you have the answers correct. So the three aspects we use when describing a numerical distribution are shape, center, and spread. Remember the shape is going to be like uniform, symmetric, skewed left or right. Center we will be talking about more in detail soon. But for now, you're just thinking about the middle or the typical value. And then spread, we've been loosely talking about as variability, thinking about like a lot of different variety in answers and things like that. So this section is mostly just kind of formalizing that in a general sense. But remember, we're going to get into those details more later. So quickly here, shape, just some more examples. Symmetric, meaning again that it's the same on the left as it is on the right of the graph. So if you were to draw a line down the middle of the graph, it's kind of like a mirror, and you have a mirror image on either side. Uniform means it's the same across the top, and remember, real life is very rarely perfect, so these are just kind of general settings. This we've been talking about right here looks roughly symmetric is what we've been calling it. But there's a new name that we're going to show you here, which is called bell-shaped. And bell-shaped curves are really important. We're going to be studying those a lot in this class. Anything that is symmetric, meaning the same on the left and the right, could be one of these three. So this first one doesn't really have a special name as far as like bell-shape or anything like that. We just say symmetric, and there's another word we'll put on that soon. Uniform, notice, is also symmetric, and then this bell shape, definitely symmetric, and it's a special symmetric one. Non-symmetric curves, we already know, are going to be called skewed right, if it's kind of distorted on the right-hand side, and skewed left, if it's distorted on the left-hand side. Quick note about outliers. These are points which don't fit the pattern, and they should be reported and considered. So some sources of outliers, I'd like you guys to think about that, and then on Monday, we'll fill in this piece together because I want to get your feedback on what you think some sources of outliers are. So but definitely be thinking about that over the weekend. Symmetry alone is not enough to completely describe the shape. As you saw above, there were three different symmetric examples I gave you there. So another thing we talk about here is mounds or bumps. You might think of it that way, that a distribution halves. So in this first example here with height, there's only one bump or one highest point, and we call that unimodal. Uni for the prefix for one, so one, and then modal, we're going to talk more about what mode is, but you might already know mode is the most frequent. So think of this as like there's only one most frequent value, one mode, unimodal. If you have two bumps, as in this one here, two places that are kind of the most frequent, two is bi, so bimodal. Bimodal, two places where you kind of have a most frequent value. And notice they don't have to be the exact same height. Oops, that was supposed to be a laser pointer. So they don't have to be the exact same height, but kind of the highest points relative to the points around them. So you can see it's like two peaks. And then if you have a lot of places that have peaks and there's more than two, we just call it multimodal. Multi meaning many. So multimodal, many points that are kind of peaking. A key distribution, like I said just a second ago, is the bell curve, which we are going to just call bell curve right now. And there is another name for it. It's called a normal distribution. So very, very soon we are going to be talking about the normal distribution and really digging into the details of that distribution. So those are shape highlights. Center, again, for right now, we are keeping it very general, just kind of like where's the typical value in the center, but it doesn't have to be the typical value. Notice in this example on the right, it's still the center that we're after, but it's not a typical value. In fact, on this distribution, the values on the ends are the typical values, but they aren't in the middle, so the center is still the middle. Okay. We'll talk more in detail again soon. Spread, again, just in general, we're thinking variability. So this isn't anything new. Low variability means most everybody's kind of in that same spot, whereas high variability, we have a lot of people in a lot of different categories. think back to those families we talked about in class the other day. All right. So at this point, you might want to pause your video and see if you can do these practice problems, and then restart it to see if you got the answers correct. So when you're talking, okay, hopefully you just paused your video. Welcome back. So when you're talking about your shape, you're identifying your shape, you want to be talking about two things here, symmetric versus skewed, and also your modality. So on this first one, I would say this is symmetric, or you might even be more specific and say it's bell-shaped, because remember we have all those different types of symmetry. So bell-shaped is a good one to be able to pull out. So symmetric, bell-shaped, and it's also unimodal, one place where there's a highest value. The shape on the second one here, definitely I would say is skewed left, kind of distorted on the left-hand side there. It is also unimodal, one place where there's a highest spot. This next one I would also still say is skewed left, though it's not quite as skewed as the first one. And this one is bimodal, two places where kind of the highest parts, if you will. Now that's kind of a little bit subjective on this one. So some of you might have said multimodal or unimodal. Unimodal would be kind of like if I was thinking about it just as a general curve like this. But I'm going to go ahead and say bimodal because these two peaks are kind of separated out from each other. And we'll get into more detail about that later. All right, this last one, last row, I'm sorry. This first one here is skewed right. And definitely unimodal, there's one peak. And then this last one I would say is skewed left and unimodal as well. Okay. So those two high bars that are next to each other are kind of considered as a single peak together. And notice the difference there in the one above it is the two peaks are kind of separated by a bar in the middle, which is why I went ahead and considered them as two different peaks, whereas here they're connected together. So if you're not sure about that on Monday, just let me know and we can go over that in more detail. For this last one here, number 2, what shape would you expect? You have to kind of think about, if you had data about these different things, what would the distribution look like if you did a histogram of it? So GPA of college students, I'm going to say is most of us are kind of in the same, general area, 2, 3 point, whatever. A few people have really high GPAs, a few people have really low GPAs. So I'm going to say it's probably pretty symmetric, but you might disagree with me on that, and that's okay. What I want to do is leave the rest of these to discuss on Monday, because I want you guys to kind of have a chance to talk about them with each other as well. So see if you can finish filling that out. And so for Monday, remember, I want you to be thinking about possible sources of outliers up here, and also try to fill in the rest of that, and we'll go over those at the start of class on Monday. Thanks, guys. Have a fantastic weekend.